Now, some numbers you don't have to worry about how many significant figures there are because they are exact numbers. Exact numbers are given by two ways. They're either counting numbers or they're done by definition. Shoot, I lost count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 20. There are 23 students here today. As long as I counted correctly, there's no error in that, is there? When did we learn how to count? Like watching Sesame Street when you were a little kid, right? Count was on there. What? Cookie Monster. Right? Eating cookies. Counting cookies. Right? No error in that. Or by definition, 12 inches equals 1 foot. What's the error in 12 inches equals 1 foot? Is there any error? No. It's by definition, isn't it? What's one that I gave you earlier that's also exact? Anybody remember? 2.54 centimeters equals 1 inch. Very good. Boy, that makes my heart feel good when people are paying attention. It does. Y'all understand why we teach. You think that we're up here just to kill y'all. That's not true. Makes me feel good if people remember what I said. Okay? So by definition, what does that mean? It means that these numbers basically have an infinite number of significant figures. When you do calculations with them, you don't have to worry about how many sig figs they have. And we'll show that when we do some calculations. Okay? So, identify each of these as exact or measured. 3 coins. It's exact, right? You can count 3 coins, right? The diameter of a circle is 7.902 centimeters. Somebody must have measured that, right? You can't count that. 60 minutes equals an hour.
Exact.
This is exact. It's always that way, isn't it? Okay. All right. Significant figures and calculations. Oh boy. Sometimes I go off the slides because I just like to do that. Now, when we do multiplication and division, why is that so bad?
There might be dust on the side.
I think. Well, that helps. Now look at what you did, Brad. Guess I don't like right? Okay. When we multiply and divide, the rule is you report your answer to the one that had the least number of sig figs. All right, let's do some examples. 5.0 divided by 2.5, and I'm not going to worry about units. What's the answer here?
2.
2? If you do it on your calculator, it's 2, isn't it?
Mm-hmm.
It is not 2. What did the rule just say? Report the same number of sig figs as you had in the number with the least sig figs here. It is 2.0. Very good, because I have to have 2 sig figs, right? Let's change it a little bit. 5.0 divided by 2.0. 2.5. Pretty easy, right? All right. What's 5 divided by 2? It is not 2.5.
It's 2.
There's only 1 sig fig and 1 sig fig. I can only report 1. It is not 2. It is 3. Your calculator tells you it's 2.5, doesn't it?
Yeah.
But the rule says this has 1 sig fig, this has 1 sig fig. I can only report 1 sig fig. 2.5 rounded off is 3. I know you all think that 5 divided by 2 is 2.5, but it's not. It's 3.
That's confusing.
Follow the rules. Don't be a rule breaker here because I'll smack your hand. Take a point off on this one, right? Sometimes you gotta follow rules. In this case, we must follow the rules or else what? People don't report numbers correctly and what? Then, well, your hand gets smacked and there's too much error sometimes, right? Okay? So you see the difference between this and this? There's a big difference in the answer, isn't there? So if you have the ability to make measurements with more sig figs, what should you do? Do it! Report all the sig figs you possibly can within the rules. Don't just go, yeah, that's about 5. Okay? Per example, let's say that you were doing a dosage or something like that, right? The difference is if you report 5 versus 5.0. What does 5 mean? 5 means it was between 4.5 and 5.4. Everything between there rounds off to 5, doesn't it? Well, there are some medications, if you give 4.5 versus giving 5.4, that's a huge difference. That's 20%. But if you give 5.0, that's the difference between 4.9 and 5.1. That's a 5. Okay? See the difference here? You always run a report as good as you can because then you don't wind up with this kind of gobbledygook. Okay? So when you multiply and divide, you always round to the one that has the least number of sig figs. Do we need to do any more examples? Let's just do a couple simple ones. Oh, let's say, oh, this is a tricky one. Don't even need a calculator. What's the answer? It is not 10.
10.00.
No.
10.0.
How do you see 10?
The answer is 10. Right? Is that good enough? Is it, can I write it like that?
No. Well, yeah. Imaginary 0.
You must write it like this. This answer is wrong. Because that would have 2 sig figs in it, right? It has to be 10 with no decimal here. Now it becomes what? 10.0. 3 sig figs in each one of them, 3 in my final answer. Okay? See the difference?
No, hey, okay, on that one, on the first one,
On this one,
yeah, there's
3 and 1.
and 1, okay.
So I can only report 1.
Why? Because what's
One
the
is
rule
less
again?
than 3.
What's the rule again?
Report the number in your answer of the one that has the least number of sig figs. So this one had 3 and this one had 1. I can only report 1 in my answer.
So the one significant figure is not the same as the number of digits in your final answer.
No, it is not.
Have you said it wrong?
When you multiply and divide, you can only report in your final answer the same number of sig figs as the number that you used originally with the smallest number of sig figs. Let's do a big example. Let's do a big extreme example.
Can only report.
Watch this. 20.00 times 2. How many sig figs are here? There are 4 sig figs here and 1 here. When I multiply these two numbers together on my calculator, I get 40, right? Is that okay?
Yes.
Yes, it is, because the way it's written, there's only 1 sig fig. Okay?